We'll close it out real quick here. Most structures don't settle. Actually, everything settles. Doesn't matter what it's sitting on, if it's sitting on rock, it's settled. It's just a little bit, but it will. The famous picture, settlement is not necessarily what kills you, it's differential settlement that really gives you trouble. If you have this whole building and it all settles 6 inches, but it's uniform, from a structural standpoint, it doesn't really matter. But if you have this wall settle 2 inches and that wall settle 6 inches, the angular distortion will create all kinds of cracks and distress on that drywall partition right there, and it's going to put all kinds of stresses on the structure that don't really work. So what kills you is the differential settlement most of the time. You guys know how they fix that, stabilize that? It's pretty gutsy stuff. They actually went on the opposite side where it's not leaning and removed material to make it settle the other way. About the brass ones on that. It's good. That's an interesting talk presentation. If you guys look it up online, it may be available with Professor Domlowski, I think. He did that presentation for us a few years ago, but it's pretty interesting. The politics of that is even worse. So, little guidelines here. Most settlements can tolerate about 1 inch of settlement total. Your differential, 1/2 inch to 3/4 of an inch. It depends on the structure. If it's an open structure, you can take more settlement. If it's a parking deck, you can take more settlement, differential settlement. But really the key, the word there is angular distortion. That's you're essentially your settlement between 2 points divided by the horizontal distance between them. And those are the values that you look at. When you see 1/500, if you can keep things in that range, you're going to be doing okay for most structures. But there's exceptions. Depending on what you're doing, if you're doing something that's going to be machining airplane parts, guess what? You're going to have to be more mindful of that. You have delicate building exteriors, some break in here sometimes. Depends on what you're doing. Curtain walls, that kind of stuff. Warehouse floors, so you're doing, if you're doing a dedicated, like a rail where you have automated, piece of equipment that goes up and down, takes loads, whatever, on high bays. You're going to have to be mindful of settlement. Swimming pools, you don't want that. And definitely, your personal housing, the homeowners are horrible. The wives have the homeowners have a tendency to exaggerate the problem. It's a sensitivity issue. On the other hand, you have other structures, water tanks, silos, your light metal buildings, NSC walls, that kind of stuff. That can tolerate a lot more deformation, and it's not a safety issue, and it works perfectly fine. But even then, particularly on walls, when you get to a certain point of deformation, everybody starts saying, "Oh, this doesn't work, it looks horrible." Deformation, settlement, it's really the key issue there. I don't know if any of you have taken reinforced concrete design, but it's the same concept. You can have a beam that has a very large capacity. It will deform 6 inches. It will be perfectly safe. Nobody's going to want to walk under that. Your design on reinforced concrete, most of the time, not on design reinforced concrete, but most of the time that design is going to be based strictly on how much that thing's going to sag. And you go work back from there. But same thing with foundations. You got to be mindful. It's not the bearing about it. It's really the settlement of the deformation.